to our last presentation into Belarus, Silk Data on AI. Nikolai talking about AI applications. You're on, Nikolai, and you've got 10, 11 minutes.
Thank you very much, Tom, for introduction me and hello everybody. Um, and my presentation will be about the plagiarism detection system that we recently released for our customer. A few, oops, sorry, a few words about our company. We are based in Minsk, Belarus, and we have 38 persons working. Our main experience, our main directions are IT services and products in the following area. Mainly, I need to point out the publishing, the education, the legal and e-health, and this presentation will be devoted to the solutions for the teaching for learning. Here is some list of our skills that we or our technologies that we are using, both for the usual software development and for IT services, and as well for the I, uh, things related to machine learning, natural language processing, and artificial intelligence in general. And we have recently invited several products. They are either in demo or in fully functional stage that are related to the finding the similarity of text, idea of semantic maps, this solution for analysis of large collections of text, summarization of text, and extraction of data from PDFs. And this story was about our customer named APT, Accounting Professional Training from South Africa. It is a partner of Johannesburg University and some other universities as well, and they provide training services for future financial experts. And one of their normal activities is to do several rounds of exams per each year. And the natural problem in last year is quarantines, lockdowns, and everybody working, studying, taking exams from home, from online. And it is not clear how to ensure that exam essays, exam scripts that their students write are not plagiarized, or there are no other issues that are easy to solve in audience, but not so easy in online. So after some communication with the customer, we identify the following requirements. First, it is the fast processing of the signal of the single exam, because they only have about 2 weeks to proceed with everything. They for each exam they have several hundreds, normally 1,000 to 2,000 and something works or scripts, and each exam script is about 15 to 45 pages, about 30 pages in average. And from the business perspective, the plagiarism is when uh, there are very close or identical half a full page, then can be possibly billions of page pairs to be analyzed. It is not possible, definitely manually. There are another issue is possibly paraphrasing, not just verbatim copies, and some legal repeated text, for example, conversation formulas, cites from laws, and so on. As far as our customers found, this case is not addressed by other anti-plagiarism solutions available on the market. So we have so on the basis of our solution for text similarity, we have implemented a couple of several features definitely for this customer. This included special pre-processing, for example, removing footers, headers, semi-empty pages, It is includes also identification of fully duplicated documents and uh, analysis of similarity between pages. And finally, our solution works as a filter and finds some maybe couple of tens of candidates for manual inspection, and usually the processing time for single exam was within 1 hour. It was quite good for the customers. They were quite happy. Here is a example of the of the UI. One of them was a similarity histogram. They wanted to see what was number of works with different uh, similarity level. And as here is a logarithmic scale in the vertical axis, here is just several tens of scripts with similarity above 60%. That is quite acceptable to for further manual analysis. And here is an example how our result of this analysis looks at the text side. It is definitely not a real exam. It is open plagiarism corpus. And the second solution was analysis of paraphrasing. It was based technically on the so-called embeddings or vector text representation, and this considers synonyms and close meaning and so on. We have implemented special algorithm of to split the documents into semantically uniform pieces, and for the and plagiarism level calculates the weighted similarity between the segments. This analysis this analysis results look like here. It is it is a matrix of similarity between these shorter segments, and then the user can see both texts and um, the keywords that are most similar to the texts in these fragments. This idea was partially based on our development. Is a so-called semantic map. Is an approach to analyze large collections of text. Here it is example or demo for the coronavirus research papers. And in as a kind of conclusion, our work was enabling solution for the customer for ensuring that no plagiarized works are in after exam. We already published the case study on our website just yesterday, I think, and we soon will update our working demo, and now we're working together with the APT on some other solutions. Thank you very much for attention. Oh,
Okay, cool. On time. Okay. Nikolai, thank you very much for that. That's very good, interesting, and that has been completely developed in house, I assume, from you guys. Yes.
sorry.
Yeah. Has been completely developed in house from your team? Yes.
Yes, exactly. We definitely used some extra libraries or known algorithms, but the whole solution was purely by us.
Okay. Question, Dirk Cal from Lidl in London. Will the system detect plagiarism if translated from a foreign language? Great question.
Not now. We were we were addressed several times for finding similar text plagiarized or just related text on different languages, but we well still working on the still researching for the solution for this.
Okay. How do you adapt the data set for different use cases? This use case searches for plagiarism from a defined set of data focused on accounting text. What if it is general text?
Oh, well, we try to start first from the business case and find the solution that is best for the data that is natural for the customer. I don't I cannot formulate some very general solution for the general texts. Normally there is some peculiarities or special things, special features um, in the documents of each customer that makes it possible to implement the optimal solution.
Okay, perhaps last question. Viral Tripathi from Colabera in New York asks, leading universities have already been using similar software. How is this different? Is it reusable for other use cases?
Oh, well, as far as I know, normally the solutions used by big universities address a different use case. They are working uh, they are preventing students stealing materials from published sources like scholarly journals and things like that. Probably universities have other solutions for the um, uh, for the exams, but neither we nor our partners don't find such things. It is not, it is different from the it is definitely different from the normal anti-plagiarism thing because we are faced on the fast processing of the well of one exam, but not on the analysis of large collection of text from the third party sources.
Okay, Nikolai, thank you very much. We're right on time. Appreciate the presentation. Very good, very interesting.
Thank you very
Jury
much, Tom.
members, thanks for the questions as well. Stick around. Fingers crossed. Vote coming very soon. I'm going to take you off the screen here. We're going to go into the main screen, and I'm going to say a couple of words and introduce the U.S. panel.